copy any usernames, passwords, or any information they use on the internet. You'll be able to modify data as it's being sent in the air, so you'll be able to inject evil code and do so many cool things on the network. Now, to do all of the attacks that I'm going to show you in here, you have two options. The first option is to run the attacks against the virtual NAT network against the Windows machine. You just need to make sure that the virtual Windows machine is connected to the same NAT network as the Kali machine. Or you can run the attacks against real computers connected to your real Wi-Fi network, and you need to make sure that you have a wireless interface connected to the Kali machine, and the Kali machine needs to be connected to your target Wi-Fi network. Now, throughout this section, I'm actually going to be using both options. So I'm going to be running some attacks against the Wi-Fi network, and I'll be running some against my virtual NAT network, just to make sure that you're comfortable with running all of these attacks in different environments and in different networks. Because like I said, it doesn't really matter how you gained your access to the network. The network type doesn't really matter either, as long as you are able to connect to the target network. Now, to practice some of the attacks that we're going to learn in the future lectures, you need to have a target machine or a victim machine. So this is a computer that you're going to target and try to hack and test the attacks that we're going to learn against. So you can do this against any machine, but I highly recommend installing target machines as virtual machines. This is great because it won't break a real computer for you if you actually break something. It's also very easy to fix. Even if you have a computer that you don't care about, it's very easy to fix virtual machines. You can just remove it and reinstall it, or store a snapshot and go back to it. Now, as we all know, Windows is a very common operating system. It's used by a lot of people. So in this lecture, I'm going to show you how to install Windows 10 as a virtual machine so that we can test some of the attacks that we're going to learn in the future against it. So we'll use this machine with scenarios that mimic a normal user that is just using their Windows to browse the internet or do whatever normal people do with their machines. So Microsoft has actually released a free versions or free virtual machines of Windows that you can download and use. These are free and you're allowed to download them, and we're downloading them from Microsoft's website. So you need to go into this link to download it. As you can see here, this is the same link. So make sure you select what host operating system you have. So if you have Windows, you click on the Windows tab. If you have Mac, on the Mac, and if you have Linux, on the Linux. I have a Mac, so I clicked on the Mac tab. And from here, make sure you select Windows 10 Stable. And make sure you select the VirtualBox image. So these are all applications that allow you to install virtual machines. At the moment, we're using VirtualBox for everything, so just make sure you use the VirtualBox image. Once you do that, you will have a zip file like this one. Uncompress it, and you will get this file right here. Now, this is a virtual machine, a VirtualBox virtual machine file. So I'm going to double click it. And as you can see now, VirtualBox is asking me to import this machine, and it's already set up the settings for it right here. Now we can import it the way it is and then modify the settings. Now, as you can see here, I have my Windows installed right here, and I'm just going to boot into it by, actually I'm going to modify the settings first, because I remember I think it gave it 4 gigs of RAM, and I think that's too much. So I'm going to go in to here and I'll set this to 2 gigs. And yeah, and set that okay, and I'll start it. And as you can see, Windows starting straight away. No need to install it. It's already installed and ready and given to us by Microsoft. Now, if you get asked for a password, then the password is literally password with a capital P and a 0 instead of the O, followed by an exclamation mark. Now, as you can see, we have a fully working Windows machine right here, Windows 10. So it's our second victim or target machine. Information gathering is one of the most important steps when it comes to hacking or penetration testing. If you think of it, you can't really gain access to a system if you don't have enough information about it. So for example, let's say you're connected to a network and one of the devices connected to this network is your target. Now for you to hack into that target, first you need to discover all of the connected clients to this network, get their MAC address, their IP address, and then from there try to maybe gather more information or run some attacks in order to gain access to your target. Now there are a number of programs that will do this for you. Examples are NetDiscover and Nmap, which do this job really well. So in this lecture, we'll start with the simpler one, which is NetDiscover, and see how to use it to quickly map the network we're connected to. And in the next lecture, I'm going to show you how to use Nmap to gather detailed information about all of the clients connected to the same network. So I have my Kali terminal in here, and if I do ifconfig, you'll see I have ETH0, it has an IP address, and like I said, this is the virtual interface created by VirtualBox when we set the Kali machine to use a NAT network. Now I also said that this NAT network behaves exactly like an Ethernet network, and as far as the Kali machine is concerned, it thinks that it is connected to a real wired network, and as you can see in here, it's telling me that wired connected. Now I have my virtual Windows machine right here. It is configured to use the same NAT network as the Kali machine. Remember, we're still in the network hacking section, so both you and the target machine need to be connected to the same network. So as far as these two computers are concerned, they think that they are connected to the same network. So what I want to do right now is use NetDiscover and see how we can use it to discover all devices connected to the same network. Now the method that I'm going to show you will work exactly the same whether you're using it against a virtual network like I'm doing right now or against real network, and even if your target is a Wi-Fi or a wireless network. So all you have to do is type the name of the program, which is NetDiscover, and then type -R to specify an IP range to search for. This needs to be a range that can be accessed by you. So right now you can see that my IP is 10.0.2.16 and I can only access IPs on the same subnet. So IPs on the same subnet start at 10.0.2.0 and they would end at 10.0.2.254 because 254 is the last IP that a client can have. So my range is going to be 10.0.2.1 and I want to search for clients that might have an IP of 10.0.2.1, 10.0.2.2, 10.0.2.3, all the way up to 10.0.2.254. So instead of manually typing all of these IPs, I can just type over 24 and NetDiscover will automatically know that I'm trying to search for all of the IPs that start at 10.0.2.1 and end at 10.0.2.254. So this is a way of specifying an IP range for the whole subnet. So if I hit enter now, you'll see that NetDiscover will show me all the IPs of the devices connected to the same network, and note that the first three parts of the IPs are always the same because they are on the same subnet. And I also have the MAC addresses of these clients, and NetDiscover is also attempting to guess the device vendor. Now if I press Q, this will quit the program, and right now we have a list of all the connected clients to the same network. Now like I said, you can also use this method to discover clients connected to the same Wi-Fi network. The only thing is right now, if I do ifconfig, you can see that my Kali machine does not have a wireless adapter. It's not connected to a Wi-Fi network. And like I said before, you cannot access the built-in wireless card from a virtual machine. Therefore, if you want to do this or run any of the wireless attacks that we're going to see in the future against a real computer in a real wireless network, you're going to need to use a wireless adapter. Now, I'm going to include links in the description that will help you pick a good adapter that works with Kali Linux. But right now I actually have one, and I'm just going to connect it and use it just to prove to you if things work on the virtual machines connected to the virtual network, they will work exactly the same against a real network with real machines. So I'm going to connect my adapter now, and if I do ifconfig, it's still not showing up. So I'm going to connect it from my devices, USB, and click on the adapter name, and let's see if it shows up now. Perfect. As you can see, I have an adapter now called LAN 0, and what I'm gonna do is I need to connect this adapter to a Wi-Fi network first before I can discover all the connected clients to this network. So I'm gonna go to my network manager, I'm gonna click in here, and you want to click on select network, and as you can see, automatically now it actually connected to a network. But in your case, you'd want to select a network and click on connect, and then it will ask you for the password. So now I'm actually connected, and you'll see if I do ifconfig again, right now LAN 0 has an IP address. So this means that it is connected to a network, and this means that we can use it now with NetDiscover. So again, I'm going to use the exact same command that I used before just to show you and prove to you that if this works against virtual machines, it will work against real machines. And the only difference is going to be the IP. So I'm going to remove this IP, and as you can see right now, my IP is 192.168.1.8. So therefore, the range that I'm going to look for is going to start at 192.168.1.1. And I'm going to leave the over 24 here because this will tell NetDiscover that I want to start at 192.168.1.1 and finish at 192.168.254. So if I hit enter now this did not work, and I know why. In order for this to work, you actually have to disable the NAT network. So to disable the NAT network, we're going to go on devices, we're going to go on network, and we're going to uncheck the connect network adapter. So now once done with this, if we just run the exact same command again, as you can see, it's discovering all the connected clients, all their IP addresses, all their MAC addresses, and it's guessing the manufacturer, and you can see it's also discovering some Apple devices here. So as you can see, it's working perfectly using the exact same command. Now I only did this just to show you that if things work against virtual machines and against virtual networks, then they will work against real machines, because these virtual machines and virtual networks are modeled over real machines, and as far as the machines are concerned, they actually think they are real computers and real machines. The second program that we'll use for network mapping is Nmap. Now in the previous lecture we used NetDiscover, and we've seen how nice it is to quickly discover all the devices connected to our network, see their MAC address, and maybe get the vendor. Nmap takes scanning to a whole new level. It might be a little bit slower than NetDiscover, but it will show you much more information about the target. So you'll be able to see the open ports, you'll be able to see the running programs or the running services on these open ports. You'll be able to determine the computer name, the operating system running on that computer. If you're in a network, you'll be able to discover all of the connected clients. You'll be able to bypass security, bypass firewalls, and so much more. Nmap is actually a huge tool, and there are books and complete courses done just to teach Nmap. The Nmap book would actually be a really good read once you're done with this course. Now, because this tool is huge, we're not going to be able to cover all of its uses, but in this lecture, I'm going to show you the basics of this tool, how to use it to discover all the connected clients and see useful information about them, and we'll actually use it more when we get to the gaining access section. We're actually going to be using Zenmap, which is the graphical user interface of Nmap. So to run it in terminal, you just have to type Zenmap, or you can find it under your applications menu. Now, as you can see, it has a very simple interface. The first thing that we see is the target input box. In here, you can put your target. You can scan any IP that you can reach, whether it's a personal computer, whether it's a server, whether it's an IP for a web server, for a website, for example, that you want to discover all the open ports and all the running services on it. Or, like what we're going to do right now, we can put a range similar to what we did with NetDiscover, and it'll scan this whole range, discover all the live IPs, all the IPs of the connected machines on the same network, and display information about them. Now we'll have a look on how to scan servers in the gaining access section. So for now, since we are still in the network hacking section, we're gonna put a range to discover all the connected clients and see useful information about them. So right now I'm actually connected to my wireless network. That's why I'm gonna specify the whole range on that network, and we've seen how to get that in the previous lecture. So it's 192.168.1.1 over 24. At the bottom, you can see the command. This is actually the nmap command that will be executed when I hit the scan button. So like I said, Zenmap, what we're using right now, is just a graphical interface that will run this nmap command in the background and show me the results. So if you know a custom nmap command, you can put it here, or if you just want to see nmap in terminal, you can literally copy this command, paste it in terminal, and it'll give you the same results that you would get if you run it here. Alternatively, if you don't really know much about nmap and its commands, you can use one of the ready profiles in here. So in this lecture, we're actually going to be using a number of these profiles, and we'll see the difference between them in terms of speed and the information gathered. So I'm going to start with the ping scan. This is a very quick scan. It literally just pings every possible IP in the range, and if it gets a response, it'll record this response and it'll show me the devices that gave me a response, which means that these are the devices connected to the network. Now, a lot of devices do not respond to ping requests even if they are alive, so the list that you'll get in this scan might not include all the devices connected to your network. Now, once the scan is done, as you can see, we can see the list of all the connected devices in here, and in here we can also see the MAC addresses for each of these devices. We also can see the vendor. So for example, we can see that the device at 192.168.1.1 is a Cisco device. This is actually my router, and it is made by Cisco, so this is correct. So we can go ahead and start looking for exploits in this device. We can also see the 192.168.1.10 is a HTC device, and again, this is a HTC phone. This is correct. And since it's HTC, then we know that it's probably running on Android. So as you can see, we're getting more information about the connected clients. Again, we can see the 192.168.1.12 is an Apple device. So it could be a phone, a tablet, or a Mac. We can see the next device is a Dell. So again, it was a very quick scan, but as you can see, it still gave us much more information than what we got from NetDiscover. The next scan that I want to show you is the quick scan. Now this is going to be slightly slower than the ping scan, but it's going to show us more information. So right now you can see that the scan is showing us the same information that we've seen before with the ping scan, but it's also showing us the open ports on each one of the discovered devices. So it's able to discover the following ports in the router, and we can see that port 80 is open. This is actually the port used for the router settings page because it runs on a web server, so this is correct. Again, we have our Apple device here that we said it might be a phone or a computer or a tablet, but we can see now it has port 22 open. So this is a port for a service called SSH, which is designed to allow remote access to the system it's running on. Again, if you go on all the other devices, you can see all the open ports and the services running on each one of these ports. Now, in the next lecture, we'll build up on this. We'll see how to gather even more information, and you'll see how important information gathering is, because we're going to use the gathered information to hack into an iPhone that is connected to the same network. Now, in the previous lecture, we had a quick look on ZenMap and how it can be used to gather information. So in this lecture, we'll build up on that. And the main scan that I want to show you right now is the Quick Scan Plus. This scan takes the Quick Scan one step further. So first of all, it'll be slower, but it's going to show us even more information. So first, we're going to be able to see the operating system running on the discovered devices. We will also be able to see the device type, whether it's a phone or a laptop or a router. And we'll be able to discover the program and the program version running on the discovered ports. So before, for example, we were able to discover port 80 is open, but we didn't know what program is running on this port or what version of this program. Getting the exact program version is really helpful when we get to the gaining access section, and you'll see then how we can use that to exploit vulnerable services and gain full control over the computers that have these services installed. Now, straight away, when you look at the results, you'll see that we got much more information than all of the scans we ran so far. So the first thing you'll notice is the icons beside the IPs of the discovered devices. These icons represent the operating system running on these devices. So right now we have the operating system for all of the connected devices. And now it's showing us the programs running on each of the discovered ports and the versions of these programs. So for example, if we look at the 192.168.112, the Apple device, on the last scan, we knew that port 22 open and we knew that SSH is running on it, but we didn't know what version of SSH was running. Right now we can see that it's running Open SSH version 6.1. So we can go on Google and look for exploits and vulnerabilities in this specific version, and we might actually find something. We'll actually talk more about that in the gaining access section. Now, if you look at the device type, you can see that it's a media device, it's a phone. So before, we knew this is an Apple device, but we didn't know whether it's a tablet, a phone, or a MacBook. Right now we know that it is a phone. It's also discovering that it's running Apple iOS 4, 5, or 6. Now it's actually running a newer version of iOS. I'm not entirely sure. I think 9 or 10, but still it's close enough. It's telling me that it's an Apple. It's telling me that it's a phone. It's running iOS. So this is really, really good. Now if we go to the next device here, the 192.168.120, this is a Linux device, and when we ran the quick scan, we were able to identify port 80 and port 49152 open, but again, we didn't know the program running or the service version running on this port. So right now we know it's Apache HTTPD 2.2.22. It's running on Ubuntu. So again, now we have the operating system, the exact version of the service running, so we can go and look for weaknesses and exploits in this specific version. And this port, we didn't even know what service was running on it. Right now we know it's a UPnP service, and the server is MediaTomb UPnP. We have the exact version again. So again, we can go ahead and look for exploits in these specific versions, and if we discover any, we'll be able to gain full control on this computer. Again, if we go down to the 192.168.122 machine, we can see that it's running a Microsoft HTTP API on port 5357. You can also browse by the services. So from here on the left, if you click on services, you'll be able to categorize the discovered clients based on the services. So if we click on HTTP, we'll see all the clients that have a HTTP service running. If you click on SSH, we can see the Apple device here. It's the only device that has a SSH service running. So let me actually show you a quick and fun example. If we go back here to the hosts and go back to the Apple device, the 192.168.112, as I said, we know it's a phone, we know it's an Apple phone, we know that it has an SSH service installed on it, running on port 22, and we know that SSH is a service that allows you to remotely execute system commands on the computer that has the SSH service installed. Now, obviously, before you can use this service, you have to use a username and a password. Once you authenticate, it'll allow you to execute system commands remotely on that computer or on that phone. Now, by default, iOS devices do not have an SSH server. Usually, when you jailbreak the phone or the device, it'll automatically install an SSH server, and the password for that server is set to Alpine by default. That's ALPINE. Now, since we know that this is an iPhone and it has port 22 open with Open SSH server, we know that this phone has been jailbroken. Now, since the phone is jailbroken, we know the password to log into SSH is Alpine unless the user changed it. Now, most users do not even know about this, and even the ones that know about this, like myself, are too lazy to change it. So it's always worth a try. If you discover a phone like this in the same network, it's always worth a try to go and try to connect to it with the default password. So I'm just going to go to my terminal and I'm going to try to connect to this phone using SSH. So I'm going to type SSH root, which is the username for the admin in Linux, at 192.168.112. This is the IP of the phone. I'm going to hit enter. It's asking me if I should trust this connection. I'm going to say yes. And now it's asking me for the password. And like I said, when the phone is jailbroken, the password is set to Alpine. So I'm going to type ALPINE. I'm going to hit enter. And as you can see, I logged in as root. So right now I have the highest privileges on the phone and I can do whatever I want on the system. And now we can use system commands to completely control the phone. Now this is a little bit ahead of time. We are still in the network hacking section, so don't worry too much about this. We'll talk more about it in the gaining access section, but it's just a quick example that I wanted to show you of how powerful information gathering is, because we literally did not exploit anything right here. We just relied on the information we gathered and we were able to hack an iPhone that is connected to the same network as us. Now, like I said, Nmap is a huge tool. I highly recommend you go ahead and try the other profiles in here, and like I said, once done with the course, I think the Nmap book would be a really good read. We'll also use Nmap much more in the gaining access section, and we'll see how we can use this information to gain full control over the computers using code execution vulnerabilities and so on. But in this lecture, I just wanted to give you a quick overview, and we'll build up on this as we go through the course. Now, in this lecture and the next few lectures, I want to start talking about man-in-the-middle attacks. These are attacks that we can launch only if we are able to intercept the communication between two devices. Hence the name man-in-the-middle attacks. So, a normal communication would look like this, where the device is directly communicating with the entity that they want to communicate with. In a man-in-the-middle attack, the hacker would be able to place themselves in the middle of the connection, allowing them to intercept and see anything that is being transferred between the two devices. Now, there are a number of ways to achieve this. The first method that we'll cover in this course is using an ARP spoofing attack. ARP spoofing allows us to redirect the flow of packets. So instead of it flowing as shown in this diagram, it would flow through my own computer. So any requests sent and any responses received by the target computer will have to flow through the hacker computer. This means that any messages, any websites, any images, any usernames, any passwords entered by the target will have to flow through my computer. This allows me to read this information, modify it, or drop it. So as you can see, this is a very serious and very powerful attack. And the reason why it is possible is because ARP is not very secure. Now, for us to understand how this works, you need to have a basic understanding of what ARP is. ARP stands for Address Resolution Protocol, and it's a very simple protocol that allows us to link IP addresses to MAC addresses. So, for example, let's say we have a network here. We have devices A, B, C, and D. They're all connected to the same network. And we have the router here for this network. We can see that each device has an IP and a MAC address. And let's assume that device A needs to communicate with device C. Now we're also going to assume that device A knows the IP of device C, but as we know so far, in order for these devices to communicate within the same network, device A needs to know the MAC address of device C, because like we said before, the communication inside the network is carried out using the MAC address and not using the IP address. So this is a perfectly normal situation where we have a client that needs to know the MAC address of another client so that it can communicate with this client. So what this client does, it uses the ARP protocol. What do I mean by that? Basically, it sends a broadcast message. So it sends an ARP request to all the clients on the network saying, who has 10.026? Now, all of these devices will ignore this packet except the one that has this IP address, which is 10.026, which is device C. So all devices will not do anything, and the only device that will respond is device C, sending an ARP response. In this response, device C is gonna say, I have 10.026, my MAC address is this MAC address. This way, device A will have the MAC address of device C, and now it will be able to communicate with device C and do whatever task that it wanted to do initially. So all of this communication is facilitated using the ARP protocol. Like I said, the ARP protocol is a very simple protocol. As you can see, all it has is requests and responses, and the whole point of it is so that we can link IP addresses to MAC addresses or translate IP addresses to MAC addresses. So a device can send a request asking for a MAC address, and then the device that has the MAC address would respond with its MAC address. So each computer have an ARP table which links IP addresses on the same network to their MAC addresses. So if I go on the Kali machine and do ARP-A, you can see my ARP table here, and as you can see, it's linking the router's IP to the router's MAC address. Now same if I go to the Windows machine and run my CMD and do ARP-A, you'll see again it's linking the router's IP to its MAC address. So this machine, anytime it needs to send any request to the internet, it will direct that request to this MAC address, to the MAC address that's associated with the IP of the router, which is 10.021. Now, this value in here can be easily modified by exploiting the ARP protocol. So let me go back to my diagrams, and right here we have a diagram of a typical network, and you can see that normally any device that's connected to the network, if it wants to send requests, it will send them to the router will go and send that request to the internet, wait for the response, and then forward the response to the device that requested it. So if the hacker or the victim or any other computer on the network wanted to send a request, they will send that request directly to the router. Now what we can do is we can exploit the ARP protocol and send two ARP responses, one to the gateway and one to the victim. We're gonna tell the gateway that I am at the IP of the victim, so the access point will update its ARP table and it will associate the IP of the target with my MAC address. We'll do the same with the victim, so we'll send it an ARP response. We're gonna tell it that I am at 10.0.2.1. So it's going to update its ARP table and associate the IP of 10.0.2.1 with my own MAC address. So the result of this, the victim is gonna think that I am the router, and the router is gonna think that I am the victim. So anytime the victim wants to send any requests, the requests will have to flow through my computer, and I'm gonna forward them to the router. And then anytime the access point or the router wants to send responses, they're gonna go to my machine because it thinks that I am the victim, and then I'm going to forward it to the victim. So as you can see, this puts me in the middle of the connection and it gives me so much power, and we'll see all the things that we can do once we become the man in the middle. Now the main reason why we can do all of this is because ARP is not secure, because first of all, clients can accept responses even if they did not send a request. So as I said before, we're going to send a response to the access point and a response to the victim, telling them that I am at a specific IP. Without them asking who am I, or without them asking for this IP, I'm just going to send a response and they're going to accept that response anyway. Not only that, but they're also not going to verify who I am. So when I say that I am at 10.0.2.7, I am clearly not at that IP because this computer is at this IP. But the access point will trust this and it'll actually update its ARP table based on the information that I send. Same goes to the victim. I'm going to tell it that I am at 10.0.2.1. It's going to trust and believe this even though I am clearly not at this IP because the access point is at this IP. So these are the two main weaknesses with ARP protocol that allow us to run ARP spoofing attacks. Now that we know how ARP spoofing works, let's see how we can run this attack and redirect the flow of data so it flows through our device. This will allow us to intercept data and see everything sent to and from a target computer, including usernames, passwords, and so on. Now there are a number of tools that can be used to run an ARP spoofing attack. You can even build your own tool, and I covered this in my Python programming course. But in this lecture, I want to show you how to use a very simple yet reliable tool called ARP spoof. Then, in the next lectures, we'll use a tool called man-in-the-middle-F because it has more features. Basically, the main reason why I want to cover ARP spoof in this lecture because it is a very simple tool, but it's very reliable. It's also ported to many operating systems, including iOS and Android. Therefore, if you learn how to use it here, you'll be able to use this tool on all of the other operating systems. So you can only use this tool to redirect the flow of data and make it flow through your computer, and then you'll have to use another tool like a packet sniffer like Wireshark to analyze this data and do more stuff with it. And we'll cover all of this later on in the course. Now using ARP spoof is very simple. First, we're gonna have to type its name, so it's ARP spoof. Then we're gonna do -I to specify the interface that is connected to the target network, and in my case it's ETH0. because that's the interface that's connected to the network. So if I do ifconfig, you'll see ETH0 is the interface that's connected. Now, as you can see, I'm going to be running this attack against my virtual NAT network. You can run this attack against any type of network, even Wi-Fi networks, and I will cover that later on in the course. But for now, just until you properly understand how this works, I highly recommend you do like I'm doing right now and test the attack against the virtual NAT network. So all you'll have to do is make sure the Kali machine and the target Windows machine are both configured to use the same NAT network. So we're going to do -T to specify the target, and my target is at 10.0.2.7. As you can see in here, that's the IP of my target. And I'm going to have to give it the IP of the gateway, which is at 10.0.2.1, as you can see in here. Now this will spoof the target, telling him that I am the router. We'll also need to run this command once more in here. So I'm going to clear the screen. And again, I'm going to do ARP spoof IETH0. And the target this time is going to be 10.0.2.1 and 10.0.2.7. So right now we're going to be telling the router that I am the victim. So the first one will fool the victim, the second one will fool the router. Now keep in mind, this attack will work against both Ethernet and Wi-Fi or wireless networks. I'm running it right now against the virtual network, which acts as an Ethernet or a wired network, but the attack can be executed exactly the same against wireless networks. All you have to do is connect a wireless adapter to the Kali machine, connect the adapter to the target network, and use it. So the same concept as the network scanner applies. You need to have a wireless adapter that works well with Kali, and you need to have that adapter connected to Kali and connected to the target network. So I'm gonna hit enter here, and I'm gonna hit enter here. And now, if we go to the target machine and run the same command, ARPA, you're gonna see that the MAC address now for the router is different than what it was. And this is actually the MAC address of the Kali machine. So right now, this Windows machine thinks the router is at this MAC address, and every time it needs to send requests, it will send it to this MAC address, which means that they will be sent to this computer right here. Now, this computer is not a router, so when it gets requests, it's actually going to stop them from flowing and going to the router. This is a security feature in Linux. So you need to enable port forwarding so that this computer would allow packets to flow through it just like a router. Now to enable port forwarding, we're going to do echo 1 to proc sysnet IP version 4 IP forward. And as you can see, this command gets executed with no issues, and right now this computer will still have its internet access, so we can go and browse any website we want. But all these requests are not going directly to the router, but they are going to this computer first, and then this computer is forwarding them to the router as shown in this diagram, and then when the responses come back, they're gonna go to the hacker first, and then they go to the victim. So, as you can see, a very simple tool. It allows us to redirect the flow of data so it flows through our computer, allowing us to become the man in the middle. And once we're the man in the middle, we can inject code in the browser of the target. We can steal usernames, passwords, see all the information that the person sends and receives, replace downloaded files with Trojans, and much more. In this lecture and the next few lectures, we're going to talk about a tool called Man-in-the-Middle Framework. And as the name suggests, this tool allows you to run a number of man-in-the-middle attacks. So let's run the tool, see how we use it, and we're gonna do a basic ARP poisoning attack exactly like we did in the previous video. If I do ifconfig just to show you my interfaces, you'll see that I have my ETH0 is connected to the internal network at 10.20.14.203. So I'm actually just gonna go on the Windows machine and do an ARPA to show you the MAC addresses. And you can see that we have the gateway at 10.20.14.1 and the MAC address ends with 3500. So we're going to run the ARP poisoning attack and see if the MAC address changes and if we can become the man in the middle. So to use the tool, the name of the tool is man in the middle F. So we're going to put the command first. Then we're going to tell it to do ARP poisoning. Then we're going to give it the gateway, so the IP of the router. And then we're going to give it the IP of our target. And then I'm going to give it the interface. So the command is very simple. It's man in the middle F, the name of the tool. We're doing ARP spoofing. Then you give it the gateway, and I spelled that wrong. So the IP of the router, and then you give it the IP of your target, and then you give it the interface. If you don't specify a target, it'll default to the whole network, to the whole subnet. The interface here, as I said, I'm specifying my wired virtual interface, but you can specify your wireless card if it's connected to the network. Now, before we can run this command, we need to install man in the middle F because it does not come pre-installed with Kali Linux. So I'm going to go down and I'm going to open a new terminal window, and I'm just going to do apt-get update to update my sources, and then I'm going to do apt-get install man in the middle F. So as we know, apt-get is the program that we use to install packages. We're telling it that we want to install a program called, or a package called, man in the middle F. I'm going to hit enter. And now it's asking me if I really want to install all of this. I'm going to say yes, hit enter, and it'll install it for me. Once this is done with no errors, this means man in the middle F is installed now, and I can go back and use it. So I have the command ready now, and all I'm going to do is just press enter to run the program. And the tool is running now. Let's go to the Windows machine, do an ARPA, and see if we manage to become in the middle of the connection. So I'm going to run ARPA again. And as you can see, the MAC address has changed to 47E9. And that is the same MAC address as the virtual interface that we have here. So it ends up with 47E9. So that means we're the man in the middle at the moment. And the tool automatically starts a sniffer for us. So instead of ARP spoof, which only places us in the middle, this tool actually starts a sniffer, which captures the data that is sent by the devices in our network. So I'm going to go to a website called vulnweb.com. And I'm just going to click on the first result. This is just a demo website to test this. I'm going to click on login to log in. And I'm just going to put the username as admin. I'll leave that. And I'll just put the password as test pass. Now keep in mind, Firefox shows this warning when you put the password through any HTTP page. So it's not because we're doing this attack. Firefox will always show this warning if the password is being sent over HTTP. And like I said, for now, we'll test this against HTTP, and in the next lecture, I'll show you how to use it with HTTPS. So I'm going to click on login, and we'll go back to Kali. And as you can see, we got all the URLs that the user clicked. So we can see that they went to vulnweb. We can see that they went to testhtml5.vulnweb.com. And if we scroll down, we can see that there was a post request sent. And we can see that the username was set to admin and the password was set to test pass. So basically, we can sniff any data, including usernames and passwords, entered by any computer that is connected to our network. Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites these days use HTTPS, and all good websites, famous websites, use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text, and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL strip. And I show how to do this in my more advanced courses. But luckily, Man in the Middle F automatically configures and starts this tool for us. So, before I even run Man in the Middle F, I'm just going to go to the target Windows machine, and we're going to go to a target website, and let's try to go to linkedin.com. And as you can see, by default, the website loads over HTTPS. So you can see the HTTPS in here. This means everything that is sent to and from this website will be encrypted. Now, what we're going to do is we're going to go back here, and I'm going to run Man in the Middle F using the exact same command that I ran before. Because like I said, it automatically starts SSL strip. So if I hit enter here, you'll see that it's telling us SSL strip is online. So basically, Man in the Middle F right now is poisoning the network and putting me in the middle of the traffic, allowing me to intercept the data sent to and from the target. And at the same time, it ran this tool, which will detect if someone is trying to access a HTTPS website and downgrade that to a normal HTTP connection. So let's see how this is going to work. I'm going to go back to my target, and before I actually go to LinkedIn, I'm going to close the tab, and I'm going to delete my browsing data because I just loaded the website. So if I load it again now, it'll load over HTTPS. So we're going to delete the browsing data and go to LinkedIn again. And as you can see, the website is not loading over HTTPS. So you can see in here, it's not saying HTTPS. This means the website is loading over normal HTTP. And if I log in, so I'm going to put a username, let's just say zaid@gmail.com, and put a password, and I'm just going to put 123456789. Now keep in mind, Firefox shows this notification anyway, even without the attack, as long as there is an input for a password in a HTTP page, it'll show this notification. So this has nothing to do with the attack that we're running right now. So I'm going to sign in. And I'm going to go back to my attacker machine. And if we scroll up, you'll see we have the username here, which is zaid@gmail.com, and the password as 123456789. And this was posted to linkedin.com. So again, as you can see, this is identical to what happened before, and the main reason is because we downgraded the HTTPS connection to a plain HTTP connection. So when SSL strip is working, all the HTTPS connections will be downgraded to HTTP. Now, since the connections are going to be downgraded to HTTP, that means the data is going to be sent in plain text, which means that we'll be able to read all the data that's being sent, just like we usually do with HTTP. Now, there is one exception, which is websites that use HSTS. Now, HSTS is used by Facebook, PayPal, and Gmail, for example. And basically, the way this works is the browser at the victim, at the target, comes up with a hard-coded list of websites that it should only load as HTTPS. So even if we try everything that we can and try to downgrade this connection to a HTTP, the browser will just refuse to load this page, because it knows that this page has to load over HTTPS. Now, so far there isn't a practical way of bypassing HSTS. There was, but that got fixed. But I will update you as soon as there is a new way to bypass it. In this lecture, we're going to learn what DNS spoofing is and how to perform it. DNS is basically a server that converts domain names, so www.google.com for example, to the IP address of the device where Google website is stored. And since we're the man in the middle, we can have a DNS server running on our computer and resolve DNS requests the way we want. So for example, whenever a person requests google.com, we can actually take them to another website because we're in the middle. So when they request it, we'll actually give them any other IP that we want, and then they'll see a completely different website than what they're expecting. So we can have a fake website running on our own web server and get requests, for example, from live.com to that website. We can have a website requesting the target person to download a backdoor. We can do anything we want, really, pretending to be any other website. So the possibilities are endless of what you can do with this attack. Let's go and see how we can do this. The first thing, I'm going to be redirecting people to my web server. So the web server is going to be running on my local Kali machine. You can redirect people to any web server anywhere you want, but in this video, we're redirecting them to our local web server. So to do that, we're going to start Apache web server. Comes in pre-installed with Kali. So all you have to do is service, Apache 2, start. And the web server has started. So the files for the web server are stored in var www.html. So I'm going to open my file manager and I'm going to go to var www.html. And if we open this, this is our index. So this is the page that will be displayed to people who browse our web server. Now you can have a whole complete website installed in here, and it will be displayed whenever a person visits your web server. At the moment, I have a really simple page that just says a simple text just as a proof of concept. Okay, so if we go to my browser and browse to 10.20.14.203, which is my own IP address, my internal IP, if we go to it, you'll see that we can see the text here. So we're all good. Let's configure the DNS server that comes in with man-in-the-middle framework. And to do that, we're going to use leafpad, which is just a text editor. And then we're going to go to etc, man-in-the-middle framework, man-in-the-middle.conf. Then I'm going to scroll down to where the A records are. And the A records are basically the records that are responsible to transform domain names or translate domain names to IP addresses. So we're going to be targeting live.com and using the star as a wildcard. So basically we're saying any subdomain to live.com should be redirected to 10.20.14.203, and that's my own IP address. So you can replace this with any IP address. For example, you can put an IP address of a remote website that you have hosted on any hosting company, or you can have it redirect into Google, for example. If you put Google's IP, any IP you put here will redirect live.com to it. So I'm going to close that, and I'm going to run my command, and the command is very simple to the commands that we were running before in previous videos. The only difference is I'm going to add one extra option, which is DNS. So it's exactly the same commands: man-in-the-middle framework, ARP spoof, gateway, target, interface, and then we added one extra option, which is DNS.